All right, today we're starting at the end, the bottom. Kind of an odd picture for the bottom line, but yeah, making sense of it all, finding the clues and setting up an equation that will make sense. Then it's all about using the algebra solving skills to solve. So a little bit of solving here. This is problem solving all the way. And then, check your answer. Does it make any kind of sense? If you're solving a little circle and you get an answer like 248,000 pi, you're probably in the wrong ballpark. So let's go back to the beginning. See what we're actually doing here. We're still in Unit 7, circles. This is Lesson 9, so it's solving problems with arc length and sector area. All right, so we're just solving problems. It's the stuff we've already learned. It's just more about the problem-solving piece, not just the definitions. So if you need the definitions, go back and look at Lesson 8. Here we go. We're going to start taking a look right at these right away. Okay, what's the angle? Well, let's see. A circle's got a radius of 10. So we're taking a look at a radius there. Know that. The arc on the circle has a length. So it's arc length, not arc angle. What's the measure of the central angle? So if you draw these things out, you kind of do a little bit of a... Here we go. You can just draw a bit. It doesn't have to be drawn to scale. Just anything will be fine. The radius is 10, and the arc length is pi. So you don't have to do a big whole perfect drawing. Just there it is. And let's go through and we'll say, okay, arc length. There's a formula for that. The formula is the arc length is, in this case it's pi, but it's actually in reference to some central angle over 360 times the circumference. So it's the whole circumference times a fraction is what it is. It's basically circumference times fraction. Circumference times a fraction of that. So we're trying to find that fraction. We know that the answer is pi, so we're trying to go back and find that angle n. Well, let's see, that diameter times pi is the circumference. So 10 is the radius, so that would be a 20 diameter pi. And at that point, we're just putting it into a calculator. So all we're really doing is saying, if you want to listen to this and follow it along, because I can't show you my calculator, it's really the pi's cancel out, so you don't have to worry about the pi's. They cancel each other, because you just divide off pi. That's the whole point. And then you really got to have a 1 over here, times 360, divided by 20, and that's what you got. You got 18 right there. So that central angle should be 18 degrees. So we're taking what we're given, we're putting it into that basic formula for arc length. There's an area formula as well for sector area. I think we'll probably see that next. And then you're solving. So you're just solving off for n, basically. You might be solving for the radius, you might be solving for the arc length, you could be solving for anything, but typically it's the angle of the radius. So that's usually what we're looking for. All right, let's see, enough information. Let's hope we have enough information here. We got a central angle. This sector measures 45 degrees. So right away we know something. That's 45 degrees. So you start labeling, draw and label. Get yourself a good working diagram of this. The area is 32 pi. So right there, that area is 32 pi. So now all we need is the area formula. And let's see, what are we solving for first? Kieran says we can find the area of the whole circle. Yes, we probably could. We don't have the radius. I still don't see the radius, so probably need that. And we could find the circumference with this, but how? Let's see. We've got the area and we've got an angle. So let's take a look at the area formula. That would be, well, 32 pi is the area. Let's just say that. And that is that same thing. It's the area of the circle times a fraction. Now the fraction here is 45 degrees, so that's 45 out of 360. That's the fraction of the area, and then the whole area is pi r squared. Well, we don't know the radius squared, but we do know there's pi. So that's what we knew, and now we're solving for the radius. All right, so if we're solving for the radius, we would just take the pi's cancel off once again. That's a common theme here, is that the pi cancels off, divide by pi, and then we multiply by 360. Basically we're multiplying by 360 over 45. The reciprocal of 45 over 360. Because when you multiply by 360, these cancels off the right side, then divided by 45. So that's what you're doing. And then when you're all said and done, you've got a number. It's a nice big number, 256. The problem is that that's really equal to r squared there, because you still have the r squared right here. So you can't forget that. And then take the square root. Guess what? That is a radius of 16. So that's if we're solving that, that's what we'd be solving. So that's, regardless of what Priya and Kieran are talking about, we don't know the circle's radius, we can solve for it. All right, so that's 9-1, that's 9-2. That's one solving for the angle, one solving for the radius. Let's see what else we got here. What else can I throw at us? Not much. That's kind of it. See, look, 9-1, 9-2, 9-3 really wasn't that big. We're going to take a look at some of the homework problems as well, but it's setting up the formulas and solving them. So let's take a look at Jada here. Jada has got a rectangle, and so first thing to do is probably draw the rectangle just for the sake of argument. Like I said, draw a picture. It helps. Just a sketch. Don't worry about being accurate. It's 5 by 4. So that's 5 by 4. And right there, I can just say right there, it's got an area of 20. 5 times 4 is 20. So that's, I'm just kind of going to get the rectangle out of the way. Then he gets a paper sector out of a circle. You don't have to draw the whole circle. You can, and why not? We'll just put one on here. There's the circle. And it doesn't matter how well you draw it. It's just a sketch. So there's the paper circle. Cuts a sector out of it. It's got a radius of 5 inches, so I'm going to label the 5. And he calculates the arc length. Just remember, just pay attention to length and area. It's one or the other. That's 2 pi. So that arc length is 2 pi. So we're just going to put that out there. That now we know which formula we're going to be using. Here's what we don't know. We don't know that angle, and we don't know this sector area. So what we're really trying to find here is the sector area. More than anything else, we're trying to find this area right in here that I'm coloring in. So that is our question, because we're comparing it. He says, well, whose paper is larger? Which is larger, the rectangle or the sector? That is the ultimate question here. So let's come back and say, okay, well, I'm going to go with, first of all, I'm going to go with I can't go with the area formula. I have the arc length, so I've got to go with that. 2 pi equals, and that's some angle I don't know out of 360. And then that's going to be times pi times the diameter. That's the circumference. You know, if you're using 2 pi r, go ahead, but it's really 2 times 5 is 10 anyway, so 10 pi. I'm using pi times the diameter for my circumference. It's the easiest formula. All right, then I'm going to pause in the action, use my calculator here, and let's see what we got. The pi's cancel again. They always do. And I got 2 divided by 10 times 360. And that solves for an angle of 72 degrees. That means that central angle is 72 degrees. Now I know that. And then after that, I'm just going for the area. So I'm trying to calculate the area. So that's going to be 72 degrees out of 360 times the area, which is going to be pi r squared, and that radius is 5, so it's just going to be 25 pi over here. And since I'm comparing whole numbers to whole numbers, this one's 20 over here. I'm going to want to actually calculate it all the way through. So let's do that. 72 divided by 360 times 25 times pi. And what do I get? 15.7. Yeah, wrong pen. So you can compare. Which one's bigger, 15.7 or 20? Well, it's obvious that the rectangle is the bigger area, so the rectangle is the bigger. That is kind of what Jada was looking at. And so that's the deal. So you might have to use both equations. Just think about what do you have, what do you not have, solving for an unknown. So it kind of comes back to this same thing. Bottom line, set up the equations that make sense for what you're looking for. Use your algebra skills. And by the way, there's really not a lot of algebra skill. It's more number sense. You're more multiplying off numbers. Pi's cancel. So let's take a look at another one here. Circle has a radius of 10 centimeters, so it's always a good idea to draw the circle. Just kind of handy. And draw a radius. And, you know, it's probably going to be some kind of arc length sector thing. So radius of 10. That means the diameter is 20. We can use that. The arc on the circle is 8 pi. Okay, so right there, that arc length is 8 pi. What is the measure of the angle that defines the arc? Okay, so this one's just a single arc problem. Not even a multiple step problem. It's a single arc problem. This is problem 2 in the homework, by the way, in case you didn't notice that. It's right there. So let's check it out. Arc formula, there's 8 pi. That is the arc length, and the arc length is defined by some angle over 360, some fraction of the circle, times its circumference. In this case, that's going to be 20 pi, because 10 plus 10, or 10 times 2 is 20. And now it's really just a calculator again. We're just kind of, you're lucky. In the old days, we had to work with all these fractions and reduce fractions, but really, we don't reduce the fraction anymore. It's just not worth it. We're using technology There's the pi, cancels. And I'm just going from, I'm starting with the 8 over here on the, just to make sure you know, I'm starting over here with this 8 right here. All right, right there. And then I'm taking everything else and I'm moving it to the other side. So I'm multiplying by 360. And then I'm dividing by 20. That's kind of what the deal is. Now, just kind of getting the n by itself over there. So let's do this. 8 times 360 divided by 20. I get an angle of 144 degrees. That's what will get me that arc. I can go back and check it. I can say, hey, well, if the radius is 10, I can go 20 times 144 divided by 360, and I get 8 pi. So I can check it that way real quick. But that's where it's at. All right, circle with a radius of 6. So I'm going to just check out another circle here. Just drawing quick circles. I like Doceri because it does draw circles really easily. So I'm just going to put my radius in there. And it doesn't matter. It's not drawn to scale. So wherever you put your arc, you put your arc. But we always know where we're working with arc lengths and sectors. So it doesn't hurt to just put them on there. Let's see, it's got a radius of 6. So I'm going to draw it right in there. And for each arc length, find the area of the sector. Okay, so they're giving you the arc length. You're always going to have to go back and find the angle, and then you have to use the angle, and then go back and find the area. So I'm actually going to erase this and make, you know what, I'll just do a couple samples here. I won't do the whole thing, just do a couple samples, then we'll call it a day here. So let's go with, if that arc length is 4 pi, well, that's going to equal the angle over 360 times. Now the radius of the circle is always 6, so it's, oops, I almost put a 6 in there. It's actually 12 pi. It's pi times the diameter. So this is going to be the same for all of these things. The only difference is that this over here on the left, this is going to change each time. But it's the same calculation again and again and again and again and again. So with that one, I'm just going to go through and say, you know what, every single time, pi is still going to cancel. And I'm so taking 4 here times 360 divided by 12, and that gives me that angle. All right, so there's my angle. So let's try that. 4 times 360 divided by 12, 120 degrees. That's a 120 degree angle. And then I'm coming up and I'm using that in the area model. So the area then will be 120 over 360. Now some people say that's 1/3, but with the calculator I just do the whole thing. And then the radius is 6, so that's going to be 36 pi, because pi r squared. So the radius squared times pi. So I can do 36, now this is no calculator required here, 36 times 1/3 of that, it's really just 12 pi. And if you just want to leave it that way, you're fine. So that 12 pi belongs with that 4 pi. And if I change this, the only thing I'm really going to change here, if I change this, I'm changing the angle. That's going to change. And so that's going to change. And really this 4 pi here is going to change. So if I do the next round, watch what changes. It's really just one thing in the calculation. So then if it's 5 pi, there's the 5. So now I'm just doing the same thing. 5 times 360 divided by 12. And that's a 150 degree angle. And now I'm running the same calculation. It's 150 divided by 360 times 36. And I got 15 pi. So you notice I'm changing one. There's only one variable really through this whole thing. So you can finish off the last two. Let's see, I might actually just do those for the sake of argument. 10. Let's see. So if it's 10, let's go through it and just check it. Like I said, my formula basically stays the same. I'm just changing this 5 to a 10. Changing that 10 there. 10 times 360 is 3,600 divided by 12. That's 300, so that's a 300 degree angle. And that means that this is going to be a bigger area, right? I mean, so the area is just going up. As the arc length goes up, the area goes up because the radius is the same. It's the same circle. So let's drop that in there. Let's put our 300 in here. And 300 divided by 360 times 36. We got 30 pi as our area. All right, so that's kind of gives you the idea. All right, bottom line. Set up that equation. You got 2 equations to work with. So for 3 sections here, this whole week so far has really been 2 equations, arc length, sector area, and then just working with them. All right. Okay, we missed Forbes, but see ya. See most of you guys on Thursday and Friday. Later.